This video, we are going to continue our discussion of the dot product and show how it applies when finding an angle between two vectors. So before we start though, let's do a trigger view. I'm given a triangle to the right there. Notice that we have a side angle side and we're trying to find the opposite side. This required the law of cosines. So we're going to review that really quick because we're going to use that to derive a formula. So I'm not going to actually do this whole problem for part B, but we're going to do a setup. Okay, the setup for law of cosines is b squared minus a squared plus c squared minus 2ac cosine of theta. So if I were going to plug this in, this is a, this is c, and we're plugging each part into that. This is theta, and we could use that to find b. Just plug everything in. Okay, we're going to do the same thing here. We're going to manipulate the equation, though. So let's take a look. That's how we would do that. I'm not going to use video time to do a trig problem because it's kind of related because we're going to use the formula, but it's not solved the same way. Okay, let's start here. Okay, notice that I have a vector u. So here's my vector u, and I have a vector v there. And then if I do the, if I want to make a triangle out of it, connecting, it's u minus v. All right, now one thing I do want to note, if we're going to talk about the sides of this triangle, it is not u, but it's the magnitude of u. The magnitude is the length of that side, not u. U is the vector. So I'm going to do this before I mess it up. There we go. So that's each side, and I'm going to use law of, because our goal here is to solve for this theta. I want to find an angle between two vectors. So this would be my law of cosines. So it is u minus v magnitude squared equals the magnitude of u squared plus the magnitude of v squared minus 2 magnitude of u times the magnitude of v cosine theta. All right, so we're going to start working this out. This is why we did in the last problem, that last example. Okay, u minus v magnitude squared is just u minus v dotted with u minus v. Let me scoot this over because I'm going to need the room. All right, this is the next one. U magnitude squared is just u dotted with u plus v dotted with v minus 2, and none of this changes. Can't make these the dot because they're not squares. Okay, so there we go. Let's multiply that left side out. So I get u dot u minus v dot u minus v dot u. We could turn those around if we wanted to. Minus v dot v plus, All right, that's the left side multiplied out. Plus, I'm just writing the left side out again. Or, sorry, right side. Don't know my left and right, I guess. All right, there we go. We have that. Now, notice this is going to cancel with that. This is going to cancel with that. All right, so what we get is we have negative, and I'm going to go ahead and flip u and v, minus 2u dotted with v equals minus 2 times u magnitude times v magnitude times cosine theta. Now, notice if I solve for cosine theta, I would divide both sides by negative 2 dot u dot v. Sorry, my handwriting is getting worse. There we go. V. Dividing both sides by that, we end up with cosine. The negative 2's cancel, and I got u dot v over the magnitude of u times the magnitude of v. We have derived the formula between for the angle between vectors. That is it there. All right, that will find, if I'm trying to find the angle between the two vectors, I take the dot product of the two vectors and I divide by the product of their magnitudes. It's a pretty nifty formula. We are going to use this quite a bit. All right, so take a look at a few things. Let's actually focus on this for a moment. If u dot v equals, let's think about this. First, let's make a note. U magnitude times v magnitude is always positive. Make sure you agree with that. They're links, so the links have to be positive. Times the links together, we get positive. All right, so this side here, sign-wise, like positive negatives, completely relies on u dot v. Since the bottom is always going to be positive, the top will determine the sign, SIGN, of my cosine. So if u dot v is greater than 0, then cosine theta is greater than 0, which means that the angle, and we're talking about cosine, which is an x value, right? We're wanting the x to be positive, so it has to be in this quadrant here, which means that this is an acute angle because it would be in this quadrant because cosine is positive. Remember, cosine is my x value. If I go past here, cosine becomes negative because we're in the second quadrant. So if u dot v is less than 0, then cosine theta is less than 0, which means that it's an obtuse angle because it's over in the left quadrant. It's all based on if it's this angle, right? If it's in positive, then it's an acute angle because cosine is positive in the first quadrant. Cosine is negative in the second quadrant because it's an x. Okay, and then we have one more that was if they're greater than 0, less than 0, but if they're equal to 0, right? What that means, the only time cosine, so cosine is equal to 0, and cosine is equal to 0 when we're straight up and down. So that means they are orthogonal. It's because our formula is completely based on the dot product for our SIGN, our sign, that we can make this observation. So here's some pictures to kind of clear that up. This is going to be extremely important for us. This is a quick way to tell if two vectors have a right angle. All right, so let's determine some angles quick. Let me grab my calculator here out of my drawer. Okay, so let's give this a shot. Okay, so we have u and v, and they want us to find the angle between the two. So I need a couple things. I need u magnitude. So u magnitude is going to be the square root. We square each one. So I'm going to do that in my calculator. 5 squared plus 1, negative 1 squared plus 7 squared is 75. So we'll leave that at that. The magnitude of v is going to be the square root of 3. All right, and then let's do we need u dot v for my formula. I like to chunk this and get each part instead of write it down and throw it in. uv, okay, so if I dot that, I got negative 5 plus negative 1 plus negative 7. So they're all negative, negative 13. So I set up my formula. Cosine theta is equal to negative 13 over, if you multiply the bottom there, 75 times 3, you get 225, and the square root of 225 is 15. Right? Make sure your theta is in, it could be either one that you want. We'll do radians always. Actually, we should always do radians with calculus unless they specify otherwise. So cosine is negative, inverse cosine of negative 13 over 15. Let me make sure my calculator's in the right mode. It is. I got that the angle is roughly 2.619 rads. We could even convert that by timesing by 180 and dividing by pi. It is roughly 150 degrees. Okay. U and W. All right. So I want to find, I already have the magnitude of U, thankfully. Still square root of 75. The magnitude of W. All right, if I do that, that's 4. 16 is 20. 100 and square root of 120. Doubting myself now. Double checking. Yep. Okay. And then I need U dotted with W. So we got 10 plus 4 plus 70. Double checking. Okay, I got 84. So that means cosine of theta is equal to 84 over, okay, let's do that. 75 times 120 is 9,000, which doesn't have a pretty square root, so I'm going to leave it the square root of 9,000. And then do my inverse cosine here. Oh, and we have a domain error. Okay, let's think about this for a moment. Let's check our magnitude of U. Magnitude of U is 25 plus 1 is 26. So let's try O plus 75. Checking W, we got 4 plus 16 plus 100. It's 120. 120 times 75 is 9,000. I'm going to recheck U dotted with V. U dotted with V, or W, sorry. U dotted with W is 10 plus 4 plus 70, which is 84, right? And then that is cosine inverse of 84 divided by the square root of 9,000. There we go, I got an answer. I don't know what happened with my calculator. Okay, theta is about 0.483361 282 rads. I wrote down the whole number, which, okay, if I want to do that times by 180, divide by pi, it is about 27.7 degrees. Okay, so that's how we find angles. There is an alternative form that we're going to use with some theory, that U dot B, and this is just solving that above equation, solving for U dot B. So there's an alternative form that we're going to use, which is manipulation algebraically. So we are going to decide if two vectors are parallel or orthogonal. So I'm going to write these in component form. My vector A is equal to 2, negative 1, 3. My vector B is 2/3, negative 1/3, 1. Okay, so we have a couple ways to check. We'll do parallel first. So remember, that is taking, can I take A and multiply it by a C to get B? That's what's in question. So I put a C times A, and that's going to equal B. And we get 3 equations from this. All right. 2C, let's do it over here. 2C equals 2/3. Negative C equals negative 1/3. And then 3C equals 1. So if we solve for C, I think this one's probably the easiest to solve for C. C is 1/3. So we're asking ourselves, hopefully, here we get C equals 1/3 just by multiplying by negative. And then this one is, okay, so if I'm going to divide by 2, so the 2's will cancel, and I get 1/3. So A is parallel to B. We don't even need to check orthogonal, because if they're parallel, they cannot be orthogonal. Those are conflicting definitions.